All right, so section 9, families of functions. We have briefly talked about transformations in the last couple of class periods, and today we're going to learn about families of functions and all of the new shapes of graphs that we've looked at. The only graph that we are familiar with in Math 1 so far is the linear graph. And so briefly, let's talk about the linear graph. So we have the linear graph. What equation are we familiar with the linear graph? What does it look like? Okay, so that format we are familiar with. Good. Y equals mx plus b. Today we're going to talk about the most basic form of all of the graphs. And so the most basic linear graph is called y equals x. That is when the slope was 1 over 1 and the y-intercept was 0. So y equals x is going to be the most basic linear equation. And if you want to write that at the top or off to the side somewhere in your note guide, y equals x is going to be known as the parent graph. We're going to talk about parent graphs today. Y equals x is going to be the parent graph for the linear family. So any graph that is a line belongs to the linear family. Now that we have that established, okay, let's talk about some of this new vocabulary or reinforce the vocabulary we're going to use today. So first of all, we're going to use the term function. We did define a function in the Overland Trail unit. A function is a relationship or an equation in which each input has exactly one output. Next, parent function. A parent function is the most basic function, equation, or graph of a certain type. And when we say certain type, that's referencing the shape. You saw on the transformation worksheet that we completed last class some graphs that looked like V's, some looked like U's, and some other shapes that we aren't familiar with yet. Okay, so the parent function, that's the most basic, could be the linear function. And again, we said that that was y equals x was going to be the parent for that. And then if I look at the next term, a family is all of the variations of the parent. So all graphs that are the same shape belong to the same family. So all lines belong to the linear family. All U shapes belong to a family. All graphs that are in the shape of a V belong to a certain family. They all have a basic equation that can be modified. And lastly, in this terminology part is something called function notation. So remember, a function was every input has one output. Function notation says f of x equals. All that is a different way of writing y equals. And I'll show you f of x equals y equals several times today, so this makes more sense. But the benefit of f of x equals is that you can replace the x with whatever you want to plug in. So for example, what I have written here in green is y equals 3x plus 2. If instead of having to write then a sentence that says evaluate when x equals 5, I could simply write this right here. And I don't have to write out a sentence. I can just say f of x equals 3x plus 2. And then I can just write f of 5. And then f of 5 tells you to take 5 and plug it in for x. We won't use function notation a lot this year in this format, but you will use it more as you transition through high school. And so we are going to start with saying f of x sometimes instead of y equals, so that you start getting familiar with it. Okay, so let's jump into our first parent equation here. Okay, and so that is the quadratic function. First of all, quadratic, the equation is y equals x squared. When you see y equals x squared, the mathematics that's happening in this equation is that you are taking x times itself. And obviously we can plug in different values for x. What that looks like in function notation is f of x equals x squared. So again, all we do is replace the y with f of x. Everyone say f of x.
F of x.
All right, so that's how we say that. What we're going to go through today is plugging in values with a table to have our graph. Okay? So in the linear equation, we've already established we had that basic format, y equals mx plus b. We don't have a format that we can utilize. So we're going to have to use the table. And off to the side there I have the phrase U shape written down. So the U shape is going to be helpful. It's helpful for me to connect the name quadratic function with U shape. Okay? So looking through this, we're going to take all of our x's and plug them in to get our outputs. And again, we're going to use the table to help us make our graph. So if I take negative 3 and I plug it in for x, that would be negative 3 times negative 3, which is 9. If you use a calculator to plug these in, you must go parenthesis negative 3 squared so that you get a positive 9. If you don't type in the parenthesis on the calculator, it's going to tell you that the answer is negative 9. And we'll talk about that more as we go through the unit or through this. But remember, when we substitute in, you should always use parentheses. So negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And so those values then become, as you know, ordered pairs that we can graph. So we'd have 0, 0, over 1, up 1, over 2, up 4. Now over 3, up 9, I'd be way up here. We can't graph that. So then I'd go in the negative direction, negative 1, up 1, negative 2, up 4, and again, negative 3, up to 9, way up here. So now that you have these points, we call these parent points. These are the points for the quadratic that fit on here. Because again, this is the most basic U shape. It's the parent graph. So you do your best to draw a U hitting the points. I did not do a very good job with my slate here. See if I can try again. There we go. And also please add arrows to your graphs as we go through this unit. So now here's my U-shaped graph that goes along. So this is the parent graph. Look at the next one, cube. So cube or cubic is very similar to squared or the quadratic, and that is the equation is y equals x cubed. The mathematics that's happening in this equation is multiplying x times itself 3 times. Function notation, simply f of x equals x cubed. Now the shape that we're going to see is going to be a vertical S shape. It's very important that you find some way to make meaning with what the graph looks like, and the name and the equation, you need to tie those 3 pieces of information together. If you don't see a vertical S after we make this graph, you need to come up with your own memory device of how you're going to remember which one is which. And the reason why is in a couple minutes we're going to go through the cube root graph. The names are going to be similar, but the graphs are going to be different. You have to come up with a way to remember the difference between them. Okay? So cubic, vertical S. So we need to cube these numbers in our table here. So again, there is no strategy for graphing this other than memorizing the parent points, and a table is how you can mathematically determine these parent points by cubing or taking the value you plug in times itself 3 times. So this would be negative 2 to the 3rd power. Negative 2 times negative 2 is 4 times negative 2 is negative 8. Negative 1 to the 3rd power is negative 1 times negative 1, which is 1, times another negative 1 is negative 1. 0 to the 3rd, 0 times 0 times 0 is 0. So we get negative 8, negative 1, 0. 1 times 1 times 1 is 1. And 2 times 2 times 2 is 8. And so these are going to be our points here that we're going to try to graph. So we'd start at 0, 0, over positive 1, up positive 1, over to negative 1, and down to negative 1. This is almost looking linear, but we're going to draw in a vertical S shape in just this moment. Over to 2, up to 8. Again, this point doesn't fit. So I only get 3 parent points with this graph. And so notice at 2, we're headed all the way up to 8. So we don't want to cross this vertical area until I get all the way up here. So you're going to try to draw a half U up that's headed towards this 2 area. Let me try that again. So you don't want to cross the vertical line of 2 in this graph, but you want this half U shape up, and then you want a half U shape headed down. And the same, you don't want to cross this negative 2 boundary, because I really wouldn't hit negative 2 until all the way down here at 8. So you want your graph to be as close to this as possible. So again, we're getting familiar with all of these new shapes. So we have a vertical S, and we just looked at quadratic, which was the U shape. And maybe you can kind of start to see quadratic, oh, I have a U in the name, U shape, and you can start tying those things together. Now cubic doesn't have an S in the name, but I see a vertical S versus the inverse of it, which will happen in a minute. Okay? So square root is the inverse of quadratic. So it's the opposite operation. So addition and subtraction are inverses of each other. Squaring and square rooting are inverses of each other. So the name here is square root. The equation is y equals the square root of x. Mathematically, that's asking us what number times itself gives you x. And the function notation is f of x equals the square root of x. The shape that you're going to see is going to be a half U shape. Now again, I just stated that square root and quadratic are inverses of each other. They undo each other mathematically, and their shapes are very similar. The quadratic is a vertical U. The square root is going to be half of a horizontal U that's going this direction. Now let's look and see exactly what that looks like. Okay? So these are the points that I picked for us to work with this square root. So let's start at the bottom with 9. If I asked you what the square root of 9 is, mathematically you'd be asking yourself, what times itself is 9? Okay, good. So our answer is 3. Square root of 4. What times itself is 4? 2. And the square root of 1. What times itself is 1? Square root of 0 is 0. Now, what if I said, what's the square root of negative 9? Negative 4 or negative 1? So the square root of positive 9 was 3. Some of you might be thinking the square root of negative 9 is negative 3. However, negative 3 times negative 3 is positive. So this does not exist in the real number system. Okay, D, N, E, this does not exist, or right now you could say there's no solution for this. So I'm going to write D, N, E here for the square root of negative 1, and that would be for all of these negatives. We don't have an answer for that. Now, later on in mathematics, there's going to be times where we have to take the square root of a negative number and we don't want to say, oh, we're done. So mathematicians have found a way to work around this. And you're going to learn about something called an imaginary number later on in Math 2 and Math 3. But for right now, if we are asked to take the square root of a negative number, we're going to say it's not possible, does not exist, something to that effect. Okay? So the graph is starting at 0, 0, over 1, up 1, over 4, up 2, and then if I went over to 9, I'd just be at 3, and it'd be way over here somewhere. So when we draw our half U shape, you wouldn't want to cross that 3, that horizontal line of 3. You'd want to just approach it. So it's this nice half U curve headed this way. And again, the negative values don't exist, and that's why our U doesn't continue down here or over here anywhere. Okay? So let's look at our next one, which is the cube root. So cube root is the inverse of cubing. Now, we might not have seen this before. So the cube root is a lot like a square root, but in the check mark area, you have a 3. So if you did not know, on square root, there's actually an imaginary 2 that could go right here. So you're taking the second root. So on cube root, we put a 3 in that check mark area of the radical sign. So the cube root of x mathematically is asking what number times itself 3 times gives you x. A little bit tougher to think about. And the numbers of cube roots that we could take to give us non-decimal answers is an even smaller list than the square roots. Function notation, f of x equals the cube root of x. And then here's why I was calling the other graph a vertical S. This one looks like a horizontal S shape, okay? And that way you can know cube and cube root are inverses of each other. Their graphs are similar but facing opposite directions. Let's look at and see what this looks like. So this is our in and out table that we're going to look at. -8, -1, 0, 1, and 8. Those are the only numbers that we can take the cube root of between -10 and 10 and not get a decimal. You can take the cube root of any number, but you get a lot of decimals if they're not these nice, perfect cube numbers. So let's start with 0. The cube root of 0. What times itself 3 times is 0? 0. 0 times 0 times 0 is 0. We could go with the cube root of 1. What number times itself 3 times is 1? 1. Now, the cube root of 8. So a number times itself 3 times. 2. 2 times 2 is 4. Times 2 is 8. Now, we can take the cube root of a negative number. Okay, because -1 times -1 is +1, but times the third -1 gives us -1. The same with the cube root of -8. We can take the cube root of negatives. Okay, so -2 times -2 is 4, times -2 is -8. So when we plot our points, we have our ordered pair values here, 0, 0, over 1, up 1, over to -1, down to -1. And then I'd have to go to 8 before I would get up to 2, and then over to -8 before I would go down to -2. So this is where our horizontal S shape is going to come into play. So I don't want to cross this imaginary y equals 2 line. I want to head towards it. With our half U shape. And then I'd want to come back down this way and head towards the -2. Try that one more time. Oh, yeah. So on the quadratic, you have like your half U this way and then your half U going back this way. I'm just not doing very good on this bottom one. Let's try it one more time. Yeah. There we go. All right, almost done. Here we go. Last one. Oh, no, we have 2 left. Second to last one. Absolute value. Absolute value equation is y equals the absolute value of x. Mathematically, what are we asking ourselves here? How far is x from 0? Function notation, f of x equals the absolute value of x. Now, after we graph our points, we're going to get a V shape. So in middle school, if you were asked, what's the absolute value of -3, -2, +2, or +1, what was the answer here? They were always what? Positive. Okay, the absolute value is always positive because mathematically we're saying how far is x from 0? It's a distance. Distances are always positive. So -3 is 3 away from 0. -2 is 2 away. 1, 0, 1, 2, and 3. And this is how this is created. So over to 3, up 3. Over to 2, up 2. 1, 1, 0, 0. So looking a little bit linear here, and then I go on the other side, -1, +1, over to -2, up 2, -3, up 3. And so now we get our V shape. Okay. And again, this is called the parent graph that goes exactly through the origin. That distance, the space between, is over 1, up 1. Okay? There's all sorts of different V shapes out there. This is called the parent graph. And now the last one, exponential. So you probably have seen an exponential curve before. The equation is y equals 2 to the x. Now that's very similar to the quadratic, which is y equals x squared. So how can we remember the difference between them? Well, on the exponential graph, the x is in the exponent spot, right? Exponential. So x is in the exponent location. So now mathematically this is saying multiply 2 times itself x number of times. Function notation is f of x equals 2 to the x. Now as far as giving it a name, I don't have a name for it except for it's just the exponential shape. If you come up with something that you are going to, how you're going to remember it, feel free to share, but no one's ever really given me a name for it yet. So if we start down here, if I take my values, first of all, here's my table of values I'm going to try is from -2 up to +3. This is what it would look like mathematically. I would take -2, plug it in for x. Take -1, plug it in for x. This is what it would look like. So let's start with the positives. 2 to the third is 2 times 2 times 2. 2 to the second is 2 times 2. 2 to the first is 2 times itself, not like only one time, basically. So it's just 2. And 2 to the 0 is 1. 2 to the -1 is a half. 2 to the -2 is a fourth. Some students really kind of struggle with the idea that 2 to the 0 is 1. We will learn, if you would like to kind of believe me at why, look at the pattern going up. So each one of these is half as big. And in our last unit this year, the Alice unit, we will learn why these answers are the way they are. Okay? So for right now, these are just going to be the parent points that we're going to remember. So this was 1/4, 1/2, 0, or 2 to the 0 is 1, 2, 4, and 8. So at 0, I'm going to be up at 1. At 1, I'm going to be up at 2. At 3, or excuse me, at 2, I'll be at 4. And then over here is going to be at 1/2 and 1/4. Now you can barely see that 1/4 dot. We're getting super close to the x-axis here. And so I'm growing really fast, exponentially big. And that's kind of how I remember that that's what this graph looks like. Kind of looks like a slide. There you go. So I'm going to draw, my curve is kind of headed up this way. Let's try that again. Okay, got an arrow on it. Now, when I head this direction to the left, do not cross the x-axis. You're going to approach the x-axis, but it'll never cross. On the parent graph, I should say. So it's going to come towards the x-axis but not cross. Okay? All right, so lastly, I just have a brief reminder for you of our transformational language. So today we're going to really focus on these parent graphs, come up with ways to remember them, and this was the language that we established last time. So shift, remember we can shift up, down, left, and right. Shifting is when the graph moves to a new spot but does not change size or shape. Vertical stretch or compress when the graph gets taller and skinnier or short and wide. And then we also have reflect. We can reflect over the x-axis or reflect over the y-axis. That concludes our notes for section 9.